Okay, this is the second video for present value annuities, finite math. Okay, I want to look at a time problem now, but I'm going to look at kind of a strange one first because I think it's kind of funny to look at this. Let's say you purchase a washer and dryer from Sears or whatever your favorite store is for $1,000. And let's say they charge a monthly rate. Now again, I'm giving you the monthly rate, not the annual rate, of 1.75% on the balance. So we know that I'm giving you the rate for I is 0.0175. Let's say your minimum monthly payment were set at $5 per month. So in other words, every time Sears sends you a bill, they only charge you $5. And you want to know how long it would take to pay off the balance. Okay. All right. Well, you could construct an amortization table for the first payment to see what's going to happen, but let me show you what's going to happen here. All right, let's go to our present value annuity formula, because that's what this is. You're making a payment of $5 a month, so that means you have an annuity, and the payments are designed to decrease the balance. And notice I said designed to decrease the balance, and so that must be a present value annuity. So this is my present value annuity formula. Let me just show you back up here. Where is it? All right, so I'm basically using this formula here. Okay, and so what I'm going to do is I'm going to plug in the present value of the purchase, which is $1,000. I'm going to plug in the payment, and then I've got 1 minus 1 plus I is 0.0175, and then I'm solving for n. So remember, I got to solve for n. And then on the denominator I have 0.0175. Okay, well, the first thing I'm going to do is divide both sides by 5. So I divide both sides by 5. I get 5 over here. Divide 5 into that, you get 200. Okay, now then I have 0.0175 in the denominator. Well, so then I'm going to multiply both sides by 0.0175. And so if I multiply this side by 0.0175, it'll cancel the denominator. And if you multiply 200 by 0.0175, you actually get 3.5. So now I get 1 minus 1.0175 to the negative n left in the numerator. Okay, now I want to get this exponential expression. I want to get this term to the other side. Well, it's a minus term. So if I move it to the other side, it changes it to a positive term. So that changed it to 1.0175, positive 1.0175 to the negative n. It doesn't change the exponent. And then when I take this 3.5 and move it to the other side, I get a minus 3.5. So what I end up with is 1 over here. See that 1 minus 3.5? It gives me negative 2.5. Okay, so now remember, when we want to solve for exponents that are unknown like this, we take logs, right? Well, if you take the natural log of 1.0175 to the negative n, and then take the natural log of negative 2.5, well, something funny is going to happen. If you put this into the calculator, it's not going to give you a real number. The natural log of a negative number is not a real number. So therefore, there's no real solution to this problem. And the reason there's no real solution is because you can only pay this off in your dreams if you're going to only pay $5 a month. And here's why. If you calculated the interest by doing just simply the PRT, the principal would be 1,000. The rate would be, what I say it was, 21% is actually the rate per year, so 0.21. And then multiply that by 1/12, that'll take you back to 0.0175. So basically, to get the interest charge, you're multiplying 1,000 by 0.0175, and you're going to get $17.50. So you're charged $17.50 in interest, but you're making only a $5 payment. So you can see that the payment doesn't even cover the interest, much less reduce the balance. So I don't think that can be legal. But anyway, you can, I just thought it was an interesting problem. Okay, let's do some samples here. Let's say you found your dream home. It sells for $120,000, and you can pay 10% down and finance the balance at 9.6% compounded monthly. This rate's actually high for today's market, but 2016 is the date in case you're watching this in future years. But it says, how much are your payments if you pay for 30 years? Okay, so for 30 years we get our amortization formula, and notice that my present value is $108,000. Why? Because I paid 10% down, and 10% of $120,000 is $12,000. So I paid $12,000 down, so that means anything you pay down you reduce from the purchase price. So $120,000 minus $12,000 is $108,000. And then I would be 0.096, that's the annual rate, divided by 12 because we have monthly compounding. And then in the denominator I have 1 minus 1 plus I to the negative n. Now n is 360 because it's 30 years, 12 times a year. So that's 360. Plug this in the calculator and you get 916.01. So that's your monthly payment. B says how much would be paid in interest. Well, I'm going to call this I1 because I'm going to calculate another interest in a minute. Okay, so the amount of interest here is you're making 360 payments of 916.01. So this is what you would pay on the home if you continued making these payments over a 30-year period. Now that's over $300,000, and if you subtract off what you could have paid if you just paid cash and not financed it, then the difference between what you're going to pay over those 360 months and what you could have paid cash is the interest that you're going to pay. So you're going to pay over $221,000 in interest over that 30 years. Now C says, let's see. C says, determine what the payoff would be after 100 payments have been made. Now you could do this with an amortization schedule, but there's actually a simpler way. If you want to know the payoff, all you're really looking for is the present value on the remaining payments. Well, if I've made 100 of the 360 payments, then I want the present value. So I want to find the present value of the remaining 260 payments, because I made 100 of those 360 payments. So that leaves me with 260 payments. So I want to find what is the present value of making 260 payments of 916.01. So that's all I have to do. So 916.01 is the payment, and I just use the present value formula, which has 1 minus 1 plus I in the numerator raised to the negative n all over I. And so $100,000 and 77.71 is the equivalent present value to 260 payments of 916.01 at this interest rate. So that's basically, this is equivalent to making 260 payments of 916.01. So that would be your payoff. So if you sold the house to someone, you'd have to pay the bank off. You'd have to pay the bank this much money to get out of the debt. So we'll talk more about that in a minute. Okay, now D part says change the rate to 8.4 and the time to 15 years and calculate the payment. I'll let you do that, but same present value. I just changed the rate to 8.4% and changed the time to 180 periods instead of 360. So notice that your payment is only about $150 more a month. And the reason I dropped the rate to 8.4 is because sometimes when you pay it off quicker, you're less risk, so they'll give you a better rate. So in this condition, under these conditions, you could pay it off in 15 years by paying $1,057.20 per month. Okay. Now the last statement says how much would be paid in interest here. Well, here you're only making 180 payments of $1,057.20. So if you take off 108,000, then that's going to leave you with 82,000 in interest that you paid. So if you consider how much interest you paid in the first scenario compared with how much interest you paid in the second scenario, you actually see that with the second scenario you save over $139,000 in interest. Let me just, you can pause the video and read this problem, but let me just show you the second part. The second part shows you actually a problem that you can solve, a time problem that you can solve using, common sense here. So Sharon has to pay off a $21,000 debt, and she's going to pay an extra $100, so she's going to pay off $494.37. And so I've given you the present value formula here with her rate, and we're going to solve for n, and we want to see how long it will take her to pay it off if she pays that extra $100. Well, divide 494.37 into this to get this number, and then multiply both sides by 0.004 to get this number, and then move this term to the left and it becomes positive. Move this term to the right and subtract it from 1, and you get 0.8301 over here. And then if you take log of both sides, I kind of skipped a step here. If you take the log of this, you can bring the exponent down and you get minus n times the log of 1.004. And then on the right you have the log of this. And then since you have a minus, you actually, to solve for n, you actually have to divide this by minus the log of 1.004, but I put the minus here. And actually this log divided by log is going to be minus, and then this minus is going to switch it back to a plus, and you're going to get 46.65, but you can't do in between payments, so we'll just say 47 months. So she's going to have to make payments for 47 months. So she's able to reduce it from 60 months to 47 months by making that extra $100 payment. Okay, go ahead and read this problem. This is a two-part problem. The first part, you have to find the present value, the amount of money that Marie needs at retirement. And then the second part, you're actually using a future value formula. So be careful, because I'm bringing in future value and I'm calculating what payment she needs to make each month in order for that payment to grow to this number here, 736,606.78, which is what she would need to be able to withdraw $5,000 over the next 30 years. So read that on your own. Contact me if you have any questions. All right, I'm going to do equity. I'm going to do it pretty quick here. I got 2 minutes to do it in. So basically what I'm going to do is the amount financed here was $64,000, and the payment's $408.74. We want to find the present value of the remaining 240 payments. So because they're going to actually, so they've made 10 years of payments, so they still have to make 20 years or 240 payments. So I'm going to find the present value on the remaining 240 payments. That's $54,391.91. So that means that when they sell their house, they still have to pay that much to the bank. Well, equity is the fair market value, which I gave you to be $120,000, minus what you owe on the home, which is $54,391.91. So when I subtract those two numbers, I actually get $65,608.09. So see, that's equity. Equity is kind of like what you could profit if you sold your home and then paid off the loan. So that's why I wanted to find the payoff here, $54,391.91, so I could figure out what the equity is based on $120,000 market value. Okay, to wrap this out, you'll have to read this. This is just another equity problem. And then down here, it shows you how you can solve for the rates by graphing, similar to what we did in the last section. So you just find the intersection of the two graphs, these two graphs, and you graph them on the calculator, find the intersection, and then where they intersect is the solution. So that's all I've got time for this section. So that wraps up the first module.